Okay, so the next thing that we'll talk about is division of polynomials. So I'm just going to start pretty small and just start out with doing things like 2x squared, or sorry, 10x squared divided by 2x. So we'll just kind of take it piece by piece. So 10 divided by 2 is 5. And if you remember the rules for exponents, when they're being divided, you just subtract. So 2 minus 1 is just x. So let's keep doing that for a few examples here. So x to the 9th over 3x squared. So this is the same thing as, well, the 3 stays at the bottom, but I have 9 minus 2, so that's x to the 7th. Negative 18x to the 10th over 3x cubed, so I have negative 6x to the 7th. Okay, here, 42 divided by negative 3. I believe that's negative 14. And then 2 minus 1, so that's just a. For the b, 5 minus 2, so that's b cubed. So you can see I'm just kind of breaking it like just, by coefficient, by the next variable, and then the following variable. So that's how I'm doing the division here. Maybe we can do just a few more examples just in case. So 20x cubed over 5x, so 20 divided by 5 is 4. 3 minus 1 is x squared. Negative 28x to 14th over 4x cubed, so that's negative 7. And then x to the 11th. Okay, and then I just have one more, so negative 56 p to the 5th, and then q to the 7th over 2p squared, and then q to the 6th. Negative 56 divided by 2. I want to say that's negative 28, but I'm just going to double check real quick. Yeah, it's negative 28 p to the p cubed, and then q, yeah, just q, because 7 minus 6 is just 1. All right. So when we get into maybe like if we have to divide 9x to the 8th plus 12x to the 6th divided by 3x squared, what we can do is, one, I'm going to set this up as a fraction. So 9x to the 8th plus 12x to the 6th over 3x squared. You can just split this up into two fractions, so 9x to the 8th over 3x squared plus 12x to the 6th over 3x squared. Still means the same thing, I just split it apart into two fractions. So focusing on the first one, 9 divided by 3 is just 3. Subtracting the 8 and 2, so I get x to the 6. Now here, 12 divided by 3, I get 4. 6 minus 2, and so I get x to the 4th. So this is my answer here when I divide them. So let's try another problem here that's similar. And this one's kind of long, but it's helpful to do examples like these. So, right, so I have to divide both of these. So I'm going to first write this as a fraction. Perhaps I should have given myself a bit more room to solve this, but that's okay. So it's the same thing as saying, okay, 10a to the 5th b fourth over 2a squared b plus, or actually, in this case it's minus 2a cubed b squared over 2a squared b, and then plus 6a squared over 2a squared b. So starting with the first one, 10 divided by 2 is 5. 5 minus 2, so that's a cubed. 4 minus 1, and that's b cubed. The second one, the 2's cancel. 3 minus 2, so that's a1, or you can actually just say a. Oh, oops, sorry, I made a mistake here. I needed to have put minus, because technically we are subtracting like the second one, so that's actually minus a. B, so like 2 minus 1, so that's just b. Then I'm going to add 6 divided by 2 is 3. The a's cancel, and so do the b's, so I just get 3. So this is my answer here when I divide. So again, I set it up as a fraction, break it apart into multiple fractions, and then I just simplify each one individually and just kind of write together as like one polynomial. And perhaps we can do a few more like this. Okay, so this is the same thing as splitting it apart as 28x to the 7th over 4x cubed plus 32x to the 5th over 4x cubed. The first one simplifies to 7x, 7 minus 3, so to the 4th, plus 32 divided by 4. I think that's 8, yeah, plus 8x, and then 5 minus 3 is 2. So that's my answer here. Okay, and then how about we do 2x cubed plus 6x squared plus 4x divided by 2x. So I'm going to write this as a fraction. I want to say feel free to, whenever I write the example, pause and try it out for yourself, and then see what you get, and then continue like this video and then see if you get the same thing as I do. I think that'd be a great way to help test your skills and see if you're able to do this on your own. So with the first one, the 2's cancel, and this is 3 minus 1, so I get x squared. 6 divided by 2, so I get plus 3, and then 2 minus 1, so I just get x. And then here, my x's cancel, and I just have plus 2, because 4 divided by 2 is 2. Okay, and I just have one more of these, like in this form. So here I'm going to break these apart. So 2x to the 4th, y to the 4th over x squared, y squared, minus 3x cubed, y 4th over x squared, y squared, and then plus 5x squared, y cubed over x squared, y squared. Okay, so here, again, step by step, so the 2 just tags along. 4 minus 2, so I get x squared. 6 minus 2, so I got y to the fourth, minus, okay, 3 tags along, 3 minus 2, so I have just x, 4 minus 2, and I have y squared. And lastly, again, that 5 tags along, the x's cancel, and I just have y. So that's my solution here. Okay, so now we're gonna try to divide by a binomial. And it's gonna be a little bit strange at first, but hopefully this kind of makes sense. So I think maybe before I get into it, I should kind of talk a little bit about long division. So just using numbers, not polynomials or anything like that for now. I just want to go over the overall concept first before I kind of get into it. So 8 goes into 37 4 times, so I get 32. And I subtract that from 37, so I have 5. And then I drop down my 1. So 8 goes into 51 6 times, so I have 48. And so I get left with 3. And then I drop down my 1. 8 goes into 31 3 times, so that's 24. And I get 7 as my remainder. Now, I guess normally we would keep going, right, and figure out the decimals, but when it comes to the division that we're doing with polynomials, we actually have to stop here. We can't really like put a decimal and stuff like that. So our answer is actually just going to be 463 with a remainder of 7. Or you can actually write this as 463 plus 7 over 8. That's also very valid. So if you notice, I put my remainder over what I was dividing by, which is the 8. So this is a form that you will see, and you'll see paralleled in dividing polynomials. But I'll kind of get into it here. So, okay, let's start small. So let's say x squared plus 5x plus 6 divided by x plus 2. So this is the same thing as saying, oh, okay, x plus 2, that's dividing x squared plus 5x plus 6. Okay, so the first thing I'm going to look at is, okay, what do I multiply x by to get to x squared? In this case, it's x, right? X times x gives me x squared. Another way you could do it is also think, oh, x squared divided by x is just x. That's another way you can see it. So at this point, I'm going to multiply x with the x plus 2. So I'm going to multiply x with this whole thing, x plus 2 here. So I have x squared plus 2x, you see? So all I did was just multiply it with each term. And just like with regular division, I subtract. So I have 0 plus 3x. And then I drop down my 6. Now, what the next thing I have to do is think about, okay, what do I multiply x by to get to 3x? In this case, it's plus 3. And, again, you can also see it as like, oh, 3x divided by x is just 3, if that helps. So again, I multiply 3 with x plus 2. So I have 3x plus 6. And I subtract these, like from here, and I get 0 as my remainder. So my answer ends up being just x plus 3. This does take some time getting used to, so don't freak out too much if you're not quite getting it in the beginning. Okay, so let's do another example here. I think I'll just go ahead and write it in this form just to save time. Okay, so again, I'm going to pay attention to the first terms, and I think about, okay, what can I multiply x by to get the x squared? Just like last time, it's still x, right? X times x gives me x squared. I multiply this with x minus 3, so I have x squared minus 3x, and I subtract that from here. So I have 2x minus a negative 3, so that's plus, right? So it's just 2 plus 3, so I have 5x. Bring down the minus 12. What do I multiply x to get the 5x? So that's just plus 5. And I multiply the 5 with the x minus 3, so I have 5x minus 15. And again, I'm subtracting that. So you see, all I'm doing is I multiply the 5 with the x and then the negative 3 to get to the second portion here that I'm subtracting. And when I subtract, I have, so it's negative 12. So it might help to write off this side too. Negative 12 minus negative 15. So that's negative 12 plus 15. And that's just 3. Now, kind of like before when I talked about the long division, I can't go further past this, right? Because there's no way I can write a decimal. So what I'll have to do when I have a remainder is you'll say, okay, x plus 5, but I'm going to add 3, but it's going to be over my, what I'm dividing by. I think it's called divisor. I guess I should know, but oh well. But it's x plus 5 plus your remainder over what you're dividing by. And this is how you would write your answer. So let's maybe try some other examples. Oops, actually, let me rewrite this. Okay, so then I look at the first terms, and again, that's still x. And so I have x squared plus 3x, and I subtract that here, so I have 1 minus 3, so that's negative 2x minus 6. What do I multiply x by to get to negative 2x? That's just going to be minus 2. So negative 2x and then minus 6. I subtract that and I get 0. So my answer is just x minus 2. Okay, and let's just do maybe one more. X plus 3 divided by x squared plus 7x plus 7. So again, what do I multiply x to get to x squared? So I have x here, so x squared plus 3x, 7x minus 3x, and I get 4x. Bring down the 10. What do I multiply x to get to 4x? And that's just a plus 4. So I have 4x plus, and again, I'm multiplying the 4 with the x plus 3, so I get 4x plus 12. Of course, the 4x's cancel, and I have to do 10 minus 12, which is a negative 2. So of course I have x plus 4, but I need to include the remainder, so that's minus 2 over x plus 3, because that's what I'm dividing by. Okay, I think I really just have 2 more examples that I want to cover, before I end this. So just 2 more. I'm going to clear this drawing here. So let's try x cubed plus 1 divided by x plus 1. So I have x plus 1 out here, x cubed. Now, what's interesting about this one is that this is kind of lacking a lot of like terms in between, like the x cubed and the 1, versus here where it goes all the way like in the descending order, like an x squared, an x, and then a coefficient, or even all of these, like they always have their terms. But this one is a bit different because it just jumps from x cubed to 1. So what I will need to do is fill in the gaps a bit. You'll see why in a minute, like why this is important to do. But I'm going to have to write plus 0x squared plus 0x plus 1. That way I'm kind of filling the gaps, and it makes the math a lot easier. So what I mean by that is, what do I multiply x to get to x cubed? Well, that's just going to be x squared, because if you think about it, x cubed divided by x is just x squared. Multiply x squared by x plus 1, so I have x cubed plus x squared. And I subtract. So 0 minus 1, that's just negative x. So this is why it's so important, because it makes it so much easier for us to line up the math together. When you don't have to like, make it kind of like messy, or like have to guess and everything. Or like get lost in our work, I guess. So I think here I can bring down just the plus 0x, which I know is strange because nothing, but trust me, this will work out. So to get from x to negative x squared, I have to multiply by a negative x. So I do so I have negative x squared when I multiply, and then minus x. So then I subtract. The x squareds cancel. 0 minus negative x, so that's just plus x. So I just get positive x. Bring down my 1, so I get x plus 1. X to get to x, that's just multiplying by 1. So I have minus x plus 1, which is just 0. So this is my answer here, x squared minus x plus x. Okay, and then I promise just one more problem, and then I'll end it here. Okay, so how I'll set this up is it'll look like this. Oh, and then again, something like kind of how I talked about the last one where I fill in the gaps, same thing here. It's almost complete. I have x to the 4th, x squared, x, and then a coefficient. I need to fill in a x cubed, so I'm going to put plus 0x cubed, and then minus 7 x squared minus 4x plus 13. Okay, so I look at what do I multiply 3x to get to 9x to 4th, and if it helps, just set up as division. So that's 3x cubed. So I just put up here 3x cubed, and then I multiply, so I have 9x to the 4th minus 3x cubed, and so I subtract, so I get 0 here, 0 minus negative 3x squared, so I have just plus 3x cubed. Bring down the minus 7x squared. So I look at now, okay, what do I get? What do I multiply 3x to get the 3x cubed? So you can see it as, okay, 3x cubed divided by 3x, which is just x squared. So I'm going to put plus x squared. Multiply, right? So I have 3x cubed minus x squared. So I'm going to subtract. So I have 0, negative 7 minus a negative x squared. So this is essentially saying negative 7 plus 1. So I get minus 6x squared. Drop down my minus 4x. And again, I look at what do I multiply 3x to get to negative 6x squared. So might help to write this out again. Negative 6x squared divided by 3x. I get negative 2x. So that's all right here. Multiply that again with the 3x minus 1. So I have negative 6x squared plus 2x. So I get 0, negative 4, negative 4 minus 2x. So I get minus 6x. And then lastly, drop down that 13. So what do I multiply 3x to get to negative 6x? That's just going to be negative 2. So multiply that, so it's minus negative 6x plus 2. So I ran out of room here, but I get 0, 13 minus 2, which is 11. So this is my remainder. So I'll make a note here that this is remainder. So my solution, which I think I'll write it up here, is all this plus 11 over 3x minus 1. So this is my answer. And I know that was a lot, but fortunately, or hopefully you don't get a problem like that. But yeah, that's how you would divide this.